we can start. So, yes, I'm Jed Ramsey. I'm the outgoing chair for the CIWEM Central Southern branch. My day job, I work at Buckinghamshire Council leading Project Groundwater. And today we're going to be looking at climate change and future extremes of water. And a particular focus for today's webinar is looking at the impacts of that. Over the next 2 days, we've got another webinar at each lunchtime. So hopefully you can maybe drop into one of those or both of those as well. Just a few little housekeeping notes. Lewis, if you want to go on a slide, please. The webinar is going to be recorded. We normally publish them on YouTube, sometimes after. And if you've got any technical issues, please use the chat feature on Zoom to report those, and we'll CIWEM in the background will try to help out with that. We will have a question session. So the format of the webinar is 3 talks followed by a Q&A, a kind of panel debate at the end. So if you have any questions as it goes through, please put them in the Q&A bit of the chat. So there's a chat and there's a Q&A. So if you use the Q&A for any questions, and at the end we will try to get through as many of those as we can. It does count as CBD today. And a little bit about CIWEM. Hopefully you've heard of CIWEM. I'm sure probably many of you are members. For those of you who are not, I am a chartered member with CIWEM. It's a really good thing to do in terms of your career, getting professional development, professional recognition, and we run great events like this as well. It's a Royal Chartered professional body and is an independent charity. So, for example, everything we've done today, and we've organised this really as volunteers as being part of the committee. Just a little bit of promo on CIWEM, what we've got coming up. So one thing I'd highly recommend taking a look at is the CIWEM podcast, which is called Planet Possible. It's put together by Nikki Roach, who's former president, and really great, interesting topics. So if you do like podcasts, I'd highly recommend having a look at those. Another couple of events we've got coming up on 6th to 8th of December. We've got the Urban Drainage Group running their annual conference, which is a real-life, in-person conference. There was really technical, good, solid content for those. And on the 11th of November, we've got Fast Track to Chartership, which, like I say, if you do want to get chartered, that's a good session to attend to help you get through that. Lewis, I think we can go on another slide. And the links to those are in the chat. Yeah, now we'll move to the talk. So I'll just introduce Jo Bradley, who's with us today. Jo's worked on many aspects of water management during her 30-year career in the UK. She's completed 28 years at the Environment Agency, where she focused on many pollution prevention topics. But in the last decade, Jo's attention has been on pollution from urban surfaces and roads. And she's worked for SDS Limited for 4 years, specifying stormwater treatment devices in SUS schemes. And in September 2020, she became Director of Operations for Stormwater Shepherds UK, where she's now dedicated to the pursuit of better stormwater management and the development of a funding mechanism to develop that management. Something personally I would really entirely support. So now I'll hand over to Jo for her presentation. Thanks.
Thanks, Jed. Next slide, please, Lewis. Thank you. So I'm talking today about managing too little and too much water, particularly using sustainable drainage systems. So I just thought, just in case that we've got any people in the room who aren't familiar with SUDS, sustainable drainage systems, I do one slide just as an intro. So SUDS are drainage systems that try to mimic the natural drainage that would have been on site before it was developed. And this is an excellent example. This is a small basin at the bottom of a residential development. It captures the surface water that runs off that development when it rains, and it reduces flood risk. And the driver for SUDS initially, for the first decade or so, was really all around flood risk, reducing flood risk and capturing water, infiltrating water and storing water on site to reduce flood risk downstream. But at the same time, a good SUDS device like this one will also deliver improvements in water quality by filtering out pollutants, and an amenity benefit for the people who live there because it's a beautiful place, and a habitat for wildlife. And this is a fantastic habitat for wildlife. I was down there 10 days ago and it was buzzing with dragonflies, and there were small birds coming in to eat the seeds off the plants. It was genuinely a really beautiful place. One thing that we've not thought enough about in SUDS design is when there's too little water. So I'm just going to talk a little bit about how do we make SUDS both climate change resilient in themselves, but also how do we get our suds to help us make our urban spaces more climate resilient. Next slide, please, Lewis. So I've talked about suds plus, or suds with knobs on. So it's about getting better at suds. We've been brilliant at suds. They've come an awful long way since we first started talking about them, but we've got, I think, into a bit of a suds rut. So we see a lot of ponds on residential developments. We see a lot of skinny mown swales that don't really do much for biodiversity. And we've got to move on, step up a notch, because every suds device, every rain garden, every basin, they have the opportunity to do magnificent things, partly for nature, so to help us with our biodiversity collapse and to reverse that, but also saving water and making water available for other people to use for other things. So we've got to get better at not only holding the water in our suds so that we reduce flood risk, but saving it so that we've got it for those dry periods and hot weather, but also sharing it. We're a bit rubbish. Not us in the room. I'm sure we're all beautiful and marvelous, but there are people who are a bit rubbish at sharing things. And I think we need to get better at recognising the opportunities to share water. And I'll talk a little bit about how that contributes to habitats for wildlife as well. Next slide, please, Lewis. This is an animation. So I just wanted to put a mention of this. This was published, I think, last week. I certainly only became aware of it last week. The State of Global Water Resources 2022. It's not an easy read. I've not read it all in detail. It's only just come out, but it definitely talks about deep, long-lasting, deep-seated droughts across certain parts of the world, but also smaller droughts, but more frequent droughts across huge parts of the world. And this requirement to recognise the value of rainwater and stormwater and to start thinking about how we can make better use of it. Next slide, Lewis, please. So just to bring that down to scale, I've gone global and now I'm going tiny, just to bring us back to focus. This is a rain garden in North London, and it's an award-winning rain garden in North London, and it's a fantastic suds device. When it rains hard, the water runs off the road and the pavements and goes into the rain garden. You can see the space there in the curb for the water to get in. The water then soaks into the ground, so it reduces flood risk downstream. The soil horizons capture some of the pollutants. The plants create a really pretty linear device of flowers and plants and shrubs at the front of a parade of shops, and it creates somewhere for pollinators to feed and small mammals to hide and insects to carry out their entire life cycle. That's all fine until it stops raining. But this was in the back end of 2022 when it stopped raining for about 6 or 8 weeks, and it basically died. And although it recovered quite quickly when it started raining and the local authority replaced some of the dead plants, the point is we've created that habitat for wildlife and then we've let it die. And so we've let all those things that rely on it die. If we're genuinely going to create habitats for wildlife in our urban spaces as part of our SUD schemes, we have to be honest about that and say this is a home or a refuge or a feeding station for insects and small mammals and invertebrates, and we have to sustain it, because otherwise everything that relies on that is dead. And so I'm going to talk a little bit more about how we can do that. Next slide, please, Lewis. And click again, because this has got some extra text. So this little hedgehog, I use this slide a lot, and I know it's sad, but this little hedgehog died in that first lockdown. Do you remember the very hot, sunny weather we had in the first lockdown? And lots of people were playing out, and lots of people were enjoying the outside space. But this little hedgehog died somewhere, I think Hertfordshire, where there was no surface water. So when it stops raining, not only do our sustainable drainage devices die back or die off, but also there's no surface water anymore. There's fewer ponds. I think 50% of the ponds in the UK have been lost in the last 30 or 40 years. There's less surface water about in people's gardens. We don't like wet places in our gardens, so we tend to eradicate them. And so creatures like this, when the rivers and the streams, the chalk streams dry up, some of the small streams, even in chalk areas like clay areas like Lancashire, some of the small streams will dry up, the ponds dry up. Small creatures like this have got nowhere to go, and they died, and lots of them died. And even this year we've had hedgehog deaths reported on social media as well. So we've got to get better. I don't want to be all twee, and talk about sort of saving little fluffy hedgehogs, but we've got to get better at recognizing that we are creating habitats for these creatures and we have to make them sustainable habitats. Next slide, please, Luce. So the best way to do that is to think about ecosystems. I'm not an ecologist, and I apologize to ecologists in the room because you know this better than me, but we have to think about the entire ecosystem, right down to the microscopic organisms in the soil horizons, the microscopic fungi, the connectivity between species through that fungal network, and then the whole ecosystem from the soil horizon into the plants, up into the trees, the tree canopy, up your green wall, onto your green roof. The whole thing has to be connected and the whole thing has to exist in its entirety. It's not good enough to have just a tree pit with nothing else around it. You need lots of tree pits, and then you need a green wall and a green roof to provide roosting and nesting and feeding opportunities for the creatures that are going to live in your tree. So start with your soil. And I challenge you all, when you're next out and about in your local town, to look for open soil horizons or open grass surfaces with soil that's accessible to invertebrates and insects, because we are eradicating them all the time. And that's where I think SUDS can really help. SUDS can start to bring back the soil, and that will be a brilliant thing. The trick then is to keep that soil moist. So I'll mention that again in a minute. Next slide, please, Lewis. And then this is my other bugbear, is lights, fairy lights on trees. Preston City Centre has a parade of trees all the way down the main road. And they're not really SUDS devices, they're just urban trees, but they're all illuminated with fairy lights. And so we create these things, and we tick a box when we do the planning application. We tick in the little biodiversity. Yes, we're creating habitat for wildlife, and then we illuminate it. So actually, it's not a habitat for anything, because anything nocturnal can't live there. Anything that needs the space and the darkness can't live there. It interferes with the water management of that tree, because it interferes with the way the tree functions, and it's just a blooming nightmare. So we need to start with the fairy lights. And also in bigger SUD spaces, be much more sensitive about how we illuminate them. I know we have to keep them safe. I know we have to keep them so that people feel safe going into them, but we can do that without lighting the entire thing and without lighting up the bushes and the trees and the shrubs and the soil and the damp, dark, soggy spaces that we've created for creatures. We mustn't then illuminate them all night, because then that spoils the effect for everybody. Next slide, please. And this is something I love. And in fact, I was at Sheffield Greater Green the other day, and the apple trees in Sheffield Greater Green were fruiting. I have to say, my daughter and I tried an apple, but they were very small and weren't quite ripe. So we regretted that. But this is something else we can do. We bring these creatures into our urban centres. We bring in birds and insects and small mammals, and then we don't feed them. We must provide food for them, but also food for us. How lovely if children walking to school or people walking around their local town can pick an apple or a damson or a fig, or perhaps figs are a bit posh, but raspberries and blackberries. We can introduce these things into our urban green spaces, both to provide food for the ecosystem, but also to provide food for ourselves and to get people talking. And I know that local authority teams will say, well, hang on a minute, the fallen fruit is a nightmare. It attracts wasps. It makes a mess. It can be slippy on the surface. But that's not a reason not to do this. That's just a reason to find a better way to manage it. And so we've got to push back harder and say, actually, we've got to do this. It isn't an option anymore. So let's get on with it. Next slide, please, Lucy. And so this is probably the crux of what I'm trying to say. We've got to recognize that the water that falls from the sky is precious. And it's not just precious for drinking water, it's precious for everything. And we have a responsibility almost to capture it and reintroduce it into the environment in a way that sustains that environment. So we talk about capturing rainwater for toilet flushing. This water butt in the image here is a smart water butt which captures rainwater for use in the garden, but also empties itself in the event of a prevailing storm. So that's a fantastic flood risk management device, because it creates disaggregated storage across all the homes in a catchment to capture rainwater in the advent of a storm. But we can use that water for watering the garden, and if we're really clever, we can use the water for flushing toilets. But we've got to get better than that. We've got to then take that water and reintroduce it back into the environment. So if every one of the shops on that street in North London had a water butt, then when that little rain garden starts to look saggy and desperate, they could water the rain garden themselves. They could take ownership of that rain garden and keep it alive themselves. And if these little water butts that we're introducing in lots of homes in water stressed areas had a leaky pipe going into a shallow dish, that would provide a water supply for wildlife that was sustained throughout the long dry period. It's about this sustainability, but also sustained provision. If we're going to create habitats for creatures, we must keep them alive. If we're going to provide water for creatures, we must make sure it's there every day. If we're going to create damp, dark spaces for creatures to hide from the heat when we have hot spells, then we must make sure they're available in those hot spells. So we've just got to get better at managing stormwater. Next slide, Lewis, please. So this is extreme, I grant you that, and I'm delighted to say it's not Britain. This is Argentina last year. But wildfires are coming, and we have had a few in Britain in urban centres. We've got moorland fires in Lancashire on the West Pennine Moors. We particularly get moorland fires. And so we need to start thinking about capturing that water. And when I talked about capturing and sharing that water, potentially we can capture that water and have it as a provision for firefighting at the same time. But this picture, I just wanted to read you a little bit of the text that went with this picture in the press release, because this came from, like I say, Argentina. And a guy called Andrea Bolocchi, who's the president of the Chamber of Tourism, said, "The animals do not have water. We leave water for the monkeys in the trees, and for the alligators, we leave 2,000 or 3,000 litres per day when we do not need it to put out the fire. The estuary is dry." So in that region, they're having to supplement water for wildlife already. And then when there's a fire, there's not enough water because they need the water for firefighting. And then the animals perish anyway. Now, I'm not saying that's going to happen in downtown Buckinghamshire anytime soon, but we need to think about that and think ahead to when those sorts of events happen in the UK, and even just drought, long hot dry spells, heat effects. We've got to manage the water now, because we're still building developments and highways and schools where we're trying to just get rid of the water as fast as we can off the surface. We do our flood risk management, we have an attenuation pond, we have our greenfield rate runoff, and we're just trying to get the water into the pond or the basin or the tank and then let it go as soon as the storm passes. We've got to get better at keeping that water and recognising its value and holding it somewhere where we can use it. Next slide, please, Lewis. Last slide, I promise. Sometimes people accuse me of being a bit twee and talking about creatures, and creatures, and I probably am a little guilty of that. But I'm conscious that this isn't the wind in the willows anymore. This is a climate crisis. Just press the button again, Lewis. I apologise. I don't apologise for this image. This is a common toad, a dead common toad. Population of toads is collapsing in this country, and we have to. That's across the board, across all species, pretty much. And we can help. We're all in this room. We're all doing water management. We can help to fix that. So that's our challenge. Last slide, Lewis, just my contact details. If anybody wants to join in. Thank you very much.
Great, thanks, Jo. Really interesting and provocative talk. We'll move straight on. So just as a reminder, if you do have any questions, pop them in the Q&A and we'll have a discussion at the end. We'll now move on to John Whitmore from JBA Consulting. John's a technical director and ecologist with a particular interest in freshwater fish. John has worked in the field of environmental science for 25 years and started his career in the fisheries function of the Environment Agency before moving to JBA in 2007. Right, John, I'll hand over to you at this point.
Thanks very much, Jed, and good afternoon, everyone. Thanks for having me at the webinar today. As Jed said, I'm an ecologist. I'm not a climate scientist, but this presentation focuses on signposting to data on the abiotic impacts of climate change that can be used in ecological river restoration and longitudinal connectivity improvement work. Next slide, please. So in terms of the content of the presentation, I'll start with some background information on the UK Government Climate Change Risk Assessment. Then I'll provide you with a quick climate projection overview where I'll signpost to some tools and guidance that you can apply to river restoration projects. And I'll also cover an example of JBA's ongoing work, which is unlocking opportunities to explore and potentially mitigate these impacts. Next slide, please. So as a quick intro to climate risk in the UK government is required under the 2008 Climate Change Act to publish a climate change risk assessment every 5 years. The most recent was the third one last year. This report provides the evidence base to inform government-led national adaptation programmes in England, Scotland, Wales and Northern Ireland. The third climate change risk assessment, in line with previous assessment, remains consistent in its central thesis. And these are, there will be substantial increases in winter daily precipitation, both frequency and intensity, and especially in Western Britain. Similarly, summers are projected to be hotter and drier, with the potential for more summer drought. And this obviously all has implications for river flows and flood and water management. These changes are likely to impact the state of freshwater ecosystems and water regulation services, including water quality and water flows in the future. So there is a clear need for adaptation. I think it's also important to recognise that climate change effects will interact with ongoing and new anthropogenic pressures, such as new and emerging pollutants, invasive species, and land use change, such as changes in growing season. So all in all, the water and environment sectors will have to continue to develop our dynamism and challenge ourselves to do better. Next slide, please. So over the next few slides, I'll highlight some of the tools that are in the public domain that are available to support the water and environment sector in planning for the impacts of climate change. Next slide, please. So the first tool I'll signpost you to today was produced from the UK Climate Resilience Project Programme. It was led by a Reading University team in partnership with CEH. And that's the UK CRI Risk Indicators Portal, which is an open access tool that engages with the most recent UK climate change projections and wide-ranging indicators, including water-related indicators. Now, these indicators are often modelled at, and therefore data is available down to 12 kilometre grid square resolution, which allows for application at a very local level. And it also provides average and extreme changes, but also seasonal and annual patterns as well. Next slide, please. So what I'll do is I'll quickly show the application of this tool by using 3 National Nature Reserve wetlands to get a sense of the abiotic impact. And what we'll look at is Caerlaverock NNR up in Dumfriesshire and Borders, Bure Marshes NNR, which is over in East Anglia, and Somerset Wetlands NNR, which is obviously down in the southwest. Next slide, please. So what's on screen now is the predicted changes in precipitation at each of those sites. Again, this data for this particular metric is available on a 12 by 12 kilometre grid square. This is based on a climate change scenario with a 3-degree increase by 2100, which is a fairly pessimistic climate change scenario, but the plotted time series does display the change, the degree of change and uncertainty, and obviously the direction and pace of change are marked, with all 3 sites showing a reduction in summer precipitation, some by quite a significant degree. Next slide, please. As Jed suggested, I'm a fish ecologist, so I'm now unashamedly going to quickly give an example from that perspective. So what I'll show is an application of the same tool, but using 2 fisheries with different projections. And I'll use the UK CRI tool again in the first instance. So again, next slide, please. So what we have here is the risk of low river flows at those 2 locations, one on the Medway in Maidstone and one up in North Yorkshire. And this is the measure of change in the likelihood of experiencing low river flows in the 10-year return period. And what's I think obvious from this is there's a much more marked regional difference, with the chance of low flows in the southeast being much greater. this is useful because the low flow parameters such as Q95, so that is the percentage of the flow that is exceeded 95% of the time, are particularly relevant in the context of water resource consenting and fish pass design. Again, I'm showing my background interest there, really. Next slide, really, please. So moving on away from the previous tool, what I'm going to look at now is the enhanced future flows and groundwater portal. Again, looking at those same fisheries, but using this really useful tool, again, produced by CEH. Next slide, please. So what we have here is a prediction of changes in flow at Q90 in the near future scenario, both on the Medway and on the Yorkshire Derwent. And we can see here that the portal indicates a reduction in flow at Q90 of between 10 and 20% in the near future horizon. So that's up to 2049, but this gets significantly worse at the far future horizon, which goes up to 2079. And this portal reports predicted reduction in Q90 flows between 40 and 60% at both locations. We at JBA in the fish pass world at JBA use this data quite a lot now to offer our clients a resilience check on all fish pass designs that we do. Basically saying we can design your fish pass to current hydrology, but we can also look at how the performance of that fish pass might change in future flows based on these sort of climate change predictions. Next slide, please. Moving away from that one, a few other tools. There's the Keeping Rivers Cool tool. So some EA colleagues on this call might be familiar with this data set. It's centered around forested riparian buffers. It can be utilised to identify riparian tree cover and the opportunities for tree planting to increase future shading of streams and rivers. And this is increasingly important as, for context, shaded channels can be 1.5 degrees lower on average than open reaches, or 2 to 3 degrees in peak temperatures. So again, another useful tool for understanding areas at risk and signposting to areas of opportunity. Next slide, please. And what this next slide shows again is just using the River Medway Maidstone Victory Angling Club example on the left-hand side. From the riparian shade portal, shows that actually there's quite a bit of shade in that reach at the moment. On the right hand side, not the example from Yorkshire, but from a site down in Somerset that gives or demonstrates how this portal shows graphically areas that currently have no shade. So again, useful to sort of steer river restoration managers in the direction of where there might be greatest opportunity. Next slide, please. A couple of other tools. The UK Lakes Observatory, again, output from the UK Climate Resilience Programme, and it provides info on water quality for 900 water bodies in the UK based on satellite observations. Next one, really useful one, the next bullet, sorry, not next slide. The Met Office Climate Data Portal. Really easy to use, an open GIS-friendly interface, which includes a large array of data sets, climate predictions, observations, and new UK shared socio-economic pathways data. It's worth just noting that that SSP can be coupled with other projections to tell us how feasible it would be to achieve different levels of climate change mitigation and what challenges to climate change mitigation and adaptation might exist. Next slide, please. So if you're interested in some adaptation resources, there are 3 examples on screen now. So catchment-based approach biodiversity pack. It was produced to support catchment partnerships and others in delivery of freshwater and wetland biodiversity projects. Next one was the Natural England Climate Change Adaptation Manual. A few years old now, but is a resource to support practical and pragmatic decision making, bringing together recent science experience and case studies, and is intended as an accessible entry point to a range of available resources and tools. And then a very recently published document by SEPA, Will the River Do the Work, which presents a framework that combines the assessment of river recovery potential with practicalities of the types of river management that are most likely to be successful at a given location. This one's also useful and it specifies recovery potential for all baseline river water bodies in mainland Scotland. Next slide, please. Nearly there. Again, three more useful publications. First one, the river water temperature projections, useful report on how temperatures in chalk stream catchments are likely to change in the face of climate change. The EA science report, what will future river ecosystems be like? That is a summary of expert opinion on how future ecosystems are likely to look in the context of climate change. And finally, the updated low flows river restoration guide. So that one was produced by JBA a few years ago. We've just updated it again for the agency. And that project is understanding how selected catchment measures can be used to enhance physical habitats during low and high flow conditions, but basically to increase adaptive capacity and resilience to future droughts and floods. Next slide, please. So that's it really. Just to summarise, there is an increasing number of easily accessible tools, and when I do say easily accessible tools, I do mean they are genuinely quite easy to use. These sorts of tools will be beneficial ahead of the fourth climate change risk assessment in 2027, which will put more emphasis on adaptation with less siloed thinking and more of a focus on economics and practicalities. Thanks all for listening. I hope you find something useful there. And yeah, any questions at the end, I'm happy to field those. Thanks, Ed.
Thanks very much, John. Really interesting talk. I've certainly got a couple of bits I'd like to dive into more. We'll come to at the end. First, we've got our third speaker today. This, if you want to go on one more slide. So we've got Professor Hayley Fowler joining us from Newcastle University, where Hayley's the Professor of Climate Change Impacts in the School of Engineering. Her research focuses on improved physical understanding of changing precipitation extremes and providing better projections for climate adaptation. So really exactly what we're talking about today. She's a fellow of the American Geophysical Union and a Royal Society Wolfson Research Fellow for her work on understanding climate change impacts on hydrological systems, extreme rainfall and flooding. She was also a contributing author to the IPCC 6th Assessment Report, and she's been British Hydrological Society President and member of the Governance Board for the Flood Hydrology Roadmap, which is still a big on piece of work for the UK. And she also advises his government through her roles on the Strategic Advisory Board and on the Science Expert Group. So fingers in a lot of pies. Hi, Hayley. Great to have you with us. And at this point, I'll hand over to you.
Thanks very much, Jed. Really nice talk so far. Yeah, I wanted to talk about something a little bit different over the next few minutes. It's going to be a bit of a quick tour through a lot of different topics, but I wanted to kind of give a flavour of what we can expect, what we're seeing now and what we can expect moving forwards into a warmer world. So next slide, please. Yeah, so it all started in the summer of 2021, and I think we'll all agree that something transformational has happened to the climate since 2021, and the last 3 summers now, including this summer, have been quite different from previous years. So summer of 2021, we had very serious flooding in Germany, and you can see the sort of severe amounts of precipitation up in that top right-hand corner there. We've seen massive other extreme events. Again, this summer, for example, in Greece, in Storm Daniel, we had 3 years of rainfall falling in 2 days. In Libya, there were reports of over 400 millimeters of rainfall falling in 6 hours. So we're seeing these really large extreme rainfall events, quite slow moving as well. In the German floods, I was involved in an attribution study, a rapid attribution study for those floods. And we found that global warming had made this heavy summer rainfall between 3 and 19% more intense, and 1 to 9 times more likely. But of course, this isn't the the only type of extreme weather we're seeing. And I think the really important thing to be thinking about, and Jo brought this up in her talk earlier on, is how do we manage all of these different types of extremes together? And we've always thought about drought and flood separately, but I think now is the time to actually start to think about some of these sequences of events and how they might manifest, and how do we start to manage some of these things together. So next slide. Coincidentally, just as the German floods hit, we'd actually been doing some work looking at some results from a convection permitting climate model with Lizzie Kendon at the UK Met Office, and this was work led by one of my postdocs, Abdullah Karaman. And we'd been looking at how storms might change in the future across the whole of Europe, including the UK, but all the way to the south of Europe. And really looking at how the rainfall from those storms could change, the intensification, but also the size and movement of storms as well. And what we'd found was that these slow-moving storms, like the one we saw in Germany, which was actually a cut-off low system, could become 14 times more common over land by the end of the century. And of course, this is really important for flooding, right? And we've seen this a few times now. If the storm moves slowly, it can dump rainfall over a very small or large catchment area, actually, for a long period of time. And so it's not just about the intensification, it's about the area of the storm and the movement of the storm as well that provides that risk of flooding. Next slide. So what we found in this study is there was a massive increase in the frequency of these very extreme storms, and storms in certainly Southern Europe had unprecedented intensities and became much more frequent in autumn months. And we're starting to see this happening already, actually, I think, as we see this warming signal emerge. And there was a substantial increase in very extreme, very large storms as well, and a massive slowdown in the movement of storms. And one thing to say here is that although the signal emerges most strongly in Southern Europe, we actually saw a doubling or tripling of the amount of convective rainfall that would fall in the summer across the UK as well. So, you know, in our summers, in these drier summers that we're projected to have in the future, and that is a signal that comes out in the UK, we'll also get much more intense storms happening at the same time. Next slide. Yeah, so we need to look at rainfall in a different way. So at the same time, the government got concerned. Yeah, massive floods in Germany. Could it happen here? So they commissioned an inquiry by the Joint Committee on National Security Strategy, looking at whether our national infrastructure is actually ready, climate change ready. Now, I could have told them that it wasn't, but actually, I mean, it's very interesting conclusion to this this study, led by Dame Margaret Beckett, and a substantial input from the House of Lords as well. And they really were very strongly worded. This report said the government needs to get a grip on climate change impacts. There's overwhelming evidence climate change is already having an impact. We're not climate ready. And I mean, the Climate Change Committee would tell you this about adaptation as well. We're getting further and further away from being climate resilient, really. But we need to recognise prevention's better than cure, and basically really think about risk management. The rest of the talk is about this. So moving on to the next slide. So what was happening in summer of 2021, and this is a slide from Paul Davies, who's the chief meteorologist at the UK Met Office, who I work with quite a lot. So there's this persistent blocked pattern is forming every summer now, and we've seen this not just in the summer of 2021, we've seen it in the summer of 2022 and again in the summer of 2023. And not only that, we're starting to see this block pattern in the other seasons as well. You can even see it in the winter, and what it does is it causes these systems, these highs and these lows, to basically stay blocked in place and cause these very persistent weather extremes. And whether those, for example, in the summer of 2021 were things like the US-Canadian heat dome, the New York floods, the floods in Germany, there were big floods in China as well, or the Siberian wildfires. These are all connected to this, what they call a wave pattern across the world. And this more wavy jet stream, perhaps caused by the Arctic amplification and the reduction in the temperature gradient between the equator and the poles, weakens the jet stream, causes these waves to become more fixed in place in these more blocked conditions. And if you move on to the next slide, you can see that this was July this year. We're seeing the same sort of pattern. Yeah, we've seen the same sort of heat waves and the same sort of floods. Again, move to the next slide. And in the summer of 2022 in Europe, this manifested as a heat dome over Europe rather than these severe floods. We saw 40 degrees in the UK. Records were broken in a huge number of locations. We've seen these records broken again in 2023. So we're seeing the conjunction of heat waves and extreme floods as a sequence around the world. It's something we need to be thinking about planning for. Next slide. You can see here, this was a recent study published in Nature Communications. There have been substantially increasing heatwave trends over the mid-latitudes, and this is almost certainly because of these more blocked conditions that we're seeing. That particularly over Europe, we're seeing not just an increase in the frequency of days per decade with a heat wave, and you can see that on the top there, but a massive increase in intensity of the heat waves when they happen. So, this is this persistent signal. When heat waves last for a long time, they become much, much hotter because of these land surface feedbacks. And because they're blocked, this blocking basically causes this persistence and this increase in the intensity of heat waves when they happen, also causing flash droughts as well, these sort of very intense drought conditions and wildfires as well. So moving on to the next slide. One of my PhD students who's just finished, Christoph Sauter, had a look at this using observations, and he actually looked at a global data set actually, but I'm just going to show the results for Europe, mainly in the top right-hand corner there. What we found was when we looked at heat waves and extreme rainfall, we found this compounding effect where after a heat wave, you're much more likely to get extreme rainfall events in these mid-latitude temperate or colder climates. And in some parts of the mid-latitudes, 40% of all heat waves are followed by these really intense extreme rainfalls that cause flash floods. And so when we're thinking about impacts actually, and particularly you can think about impacts on water quality, for example, where you get much drier soils, then followed by flash floods, you get more sediment movement, issues with water quality, or for example, embankment failures, or there's lots of issues where that sequencing matters, and this compounding has an effect on impacts. Next slide. And yeah, this is just to show you sort of this is what we saw a month ago or so, a couple of months ago now. You can see Storm Daniel over Greece. You can see the big Omega block heat wave over Central Europe, and you can see the big storm over Spain. Of course, that Storm Daniel went on to become a tropical cyclone or a medicane in the Mediterranean, and then hit Libya and caused around 20,000 deaths when the major dams burst. These sort of systems are things we really need to be thinking about, I think, and I do think that we need to be really thinking about how we update our flood risk estimation methods to account for some of these changes that we're seeing and some of these more persistent systems and the sequencing of events. Next slide. One of the things we have looked at, and this is another of my PhD students who's now finished, Roberto Villalobos Herrera. This paper's about to come out in Journal of Flood Risk Management, and it was in collaboration with some people at JBA as well. We looked at whether the FSR storm profiles are actually adequate and compared them to basically a data set we had of the UK for real storms. You can see in the top right-hand corner there, that's Storm Desmond. You can also see in the bottom right-hand corner what that looks like using the FSR centered approach in blue and what the actual storm looks like in red there. You can see they actually look quite different. And the reason that we get these centered storms in the FSR is just the methodology that's used. So if you go to the next slide, if we actually look at real storms and come up with a set of real design storms based on the profiles of different duration storms and different storms in different seasons, what we find is that we come out with quite different profiles to what we see in the FSR. And in fact, short events of less than 3 hours have sharp, high intensity front-loaded profiles. Quite, more than 50% of them have these profiles. They can easily exceed the FSR 50% summer profiles peak intensities, which is quite concerning for design. Long events tend towards flatter centered profiles. And what we find as well is that we don't actually find differences between summer and winter profiles at all. It's only based on the duration of the storm. So I'm going to leave that there, move on to the next slide. There's lots of other things we should be thinking about in terms of flood risk estimation. And I mean, these include things like non-stationarity, the intensity and climate allowances that we should be adding for climate change, but also I think areal reduction factors as well, and moving beyond point methods for flood risk estimation. But just to conclude, I think that some of the things we need to be thinking about are more than, we shouldn't no longer be in silos. We shouldn't be thinking about drought and flood separately. We need to be thinking about managing water as a system, because actually we are going to see many more of these heat wave, flash droughts, even longer droughts as well, connected to and followed quite quickly by floods. So we've got to think about managing these different extremes together. And these sequences might be really important for some impacts. So I think that's another thing we need to really be thinking about. Worryingly, global climate models actually significantly underestimate the changes we're seeing in the real world in terms of these blocked conditions. So that's another thing to think about. How do we actually come up with suitable management strategies for climate adaptation if our global climate models aren't telling us what is happening in the real world now? So I think I'm going to leave it there, but I think there's lots to do, and there's some really interesting work going on in the climate field that's actually really relevant for hydrologists. And there's a definite need to bring a lot of this new science across into practice, whether this is from climate science or from flood risk science as well. Thanks very much.
Great, thank you, Hayley, and thanks to the other two speakers. We've got about minutes or so for some questions. Lewis, if you want to start sharing, yes, the other speakers, if you'd like to come back in the room. What I'll start with is, I mean, it's quite worrying, isn't it? I mean, I think the worry was a general theme of all three talks, and even someone like myself who works in the water flooding field for all these years, I found quite a lot of those statistics worrying. I think perhaps if we go to John, so I used to manage a chalk stream trout fishery, and seeing some of the stats you showed up with the increased risk for drought and low river flows, again, hugely worrying. I just wonder what do you think that's perhaps the greatest threat to freshwater ecology, those extremes? What's your view on that?
I certainly think water resources, changing water resources represents a massively significant threat to freshwater ecology. Again, answering the question through my lens of sort of interest in fish and fish ecology, I think habitat fragmentation and compromise to sort of longitudinal connectivity is going to be a really significant thing, with a reduction in summer flow, really. We already know that weirs represent significant barriers to longitudinal connectivity, and there are literally hundreds of technical fish passes that have been designed and built over the last 100 years or so. More recently, they've been designed to work across a particular sort of range of flows, and how is their performance really going to change in the context of ever decreasing sort of summer flows in the context of climate change. Just one last thread to this as well, Jed. We recently supervised an MSc project with Leeds University, and we looked at culvert prevalence across England. We just looked at Environment Agency, Network Rail and Canal and River Trust data, but just asset data from those three organisations alone suggested that there's at least 65,000 culverts across England, managed by those three organisations. And we took a tiny sample of some of those culverts and modelled the hydraulics in those. And in a future hydrology situation, the ability of fish to pass through those culverts decreased quite markedly. So we've already got weirs which we know are stopping fish moving within the catchment. How much more significant are culverts going to be? Are we going to get to a point where flows are altered so much that actually culverts are really going to start to become significant barriers to longitudinal connectivity?
Thanks, John. Interesting point. I've worked on deculverting projects before, and it's surprising the local resistance you get to opening up rivers. People don't want their rivers necessarily open, and we haven't even got to the impact on fish. I mean, that's a new one for me as well. Joe or Hayley, did you want to add anything on that topic that John's raised there? Yeah.
No, I only to remember the wider impact of low flows on the wider ecology. It's not just the aquatic species; it's the species that rely on the river system for their water supply. It's huge. It's huge and scary.
Yeah, absolutely. Hayley, do you know, you mentioned about the need to update the flood estimation methods. Do you know, are there any plans in place for that to happen? I presume they must get updated occasionally anyway, but it seems maybe there's a bit more urgency about it than perhaps than previously was.
Yeah, I mean the design storm profiles haven't been updated since 1975.
Oh.
But you're right that certain parts have been updated periodically through the flood estimation handbook, but other bits haven't been updated. I don't know. I mean, I think that there's quite a few things that could be done. I mean, I think the other thing is even in terms of the models that are used, they could be updated as well. So hydrodynamic models, hydrological models. There's much better things available now, certainly in academia, which could be pushed across and used. I'm hoping that a lot of this will happen as part of the flood hydrology roadmap and those projects. And certainly they have an initiative within that to review what's out there and try and bring this through every 3 or 5 years. So, you know, if you can have kind of a system in place to actually look at the sort of latest science, if you like, or whatever's happening in academia, and then try and bring that through a bit quicker into practice, because it's quite, I mean, I was born in 1975, so it's quite a long time ago, basically, since some of these things have been updated, nearly 50 years. It would certainly be good to update things on a slightly faster cycle than that.
Yes, I mean, there's a challenge there, the link between academia and practice. You know, it's one, as someone who works with people on both sides, getting the two to work together is challenging in itself. So, but it does need to happen. I would certainly agree with you. Joe, I think if I go to you next, so one of the things that struck me from your talk, which goes back to this of how we make the system best adapt to what we're doing, is the funding system. To me is currently upside down, and I'm really talking about the flood risk funding, which is where most of the money is in our sector, is in flood risk. So at the moment, it goes towards protecting property. You know, how many houses have you reduced from one flood risk ban to another? That's where, you know, the £1 billion over 5 years or whatever it is, that's where it all goes. And what it seems, and, you know, I think we're probably on the same page that needs to fundamentally change to focus on the wider benefits of the type of work that you were describing, you know, SUDs and schemes that bring a whole range of benefits to both ecology, people, and everything else. I just wonder what your view is on perhaps what needs to change and how we might how we might go about that as an industry. It's a big question, but yeah.
Yeah, and two things about that. One is, yeah, the funding's tricky, and other international models have a stormwater utility levy or a stormwater fee that everybody pays, and that creates a stormwater management fund that is usually spent by a team within the equivalent of our local authorities, and they do all the stormwater management, the SUDS maintenance, stormwater movement, stormwater that sort of thing. That's never going to happen here, or certainly not in the next decade. If I say the words new taxation, people wince, so that's not happening. So, but there are routes. So the water companies have just been given permission to spend £56 billion on storm overflow reduction. So a lot of that will be spent on retrofit SUDS in urban areas. And if Schedule 3 is enacted, Schedule 3 of the Flood and Water Management Act is enacted, then that creates a mechanism whereby developers pay local authorities to oversee the delivery of SUDS on new developments. That my problem with that's good. I like both those things, but they don't go far enough because they don't deal with the existing networks and existing infrastructure, which is, I don't know how we do that short of new tax. People will know that highway runoff is my pet thing, and I don't know how we pay for that short of a tax on tyres and fuel. But the other thing that keeps me awake at night, as many things do, is the speed at which we're moving. It's way too slow, because people are doing research right now on toxins in rivers. That research will take another 3 years to complete, and then it'll have to be peer reviewed, and there'll have to be a viva, and then it'll be published, and then we'll all think about it. And Hayley talked about, updating models and updating legislation, and it all takes literally 10 years potentially. I know I've worked with designers on treatment schemes for SUDS devices, and it's taken 7 years to do the design work. We haven't got 7, 10, 15 years. And I don't know how we've got to make a much faster route from research to delivery. So we do some research, we go, oh my God, there's a problem. How do we fix it? Let's fix it now. Instead of going, oh, there's a problem, let's write some guidance. We've got to get quicker. And I don't know how we do that. I'm pleased to see, actually, I've just noticed on my LinkedIn, there's a lot of young people in the room. That's where this will happen. It's the youngsters who will do this, because a lot of us who've been in the public sector for a very long time are a bit, we're familiar, we've got in those boring grinding processes are embedded within us. We need new, slick, fast moving people. Hurrah for them, I hope.
Yeah, thanks, Jo. Just got a couple of minutes. Does anyone like to make a final comment before I close for the day? Okay, well, great. Well, I'll just say thanks again to Hayley, John, and Jo for speaking today. And please do tune in again, same time tomorrow, same time on Thursday for another series of really interesting talks. So yeah, on that, we'll close it today. Thanks, everyone.